Next, I would like to invite Aditya Bhat onto the stage. Aditya is the co-founder and the CEO of AIRPROBE. Aditya is involved in building technologies to make renewable energy reliable and operationally efficient. So Aditya, from AIRPROBE, over to you, Aditya. Please welcome.
Hello, everyone. I'm Aditya Bhat, co-founder and CEO at AIRPROBE. Thank you so much for the invitation to speak over here. Just a quick introduction about AIRPROBE. At AIRPROBE, we use drones and computer vision to increase reliability and operational efficiency of solar PV. We're currently present across 5 continents, and we've inspected 12 gigawatts of solar till today. And our thought process is there is so much energy loss right at source, which we could save if we would be able to measure and identify them, right? And we think the amount of loss at that particular source is so high because these are large infrastructures. As you can see in the slide, basically solar PV plants which are coming up right now are all utility scale PV plants. And in fact, one of the fastest growing renewable energy sources today, right, across the world. And what we see is because these solar plants are so large, what I mean by so large is a typical PV plant is 100 megawatts today, which is 400 acres of land. There are a lot of problems because energy needs to be cost effective. So you don't really monitor them effectively, right? As you can see in slides, the small boxes which you see are these solar PV panels which produce electricity. There's a lot of them connected with each other, right, which basically builds up the voltage and produces electricity. And this is what we call as DC energy, which is then converted into AC through those rooms which you see as inverters. The PV plants are monitored at these inverters, which means if some of these panels have issues, you're not even able to identify them because there's no sensors over there because it becomes so expensive. So what do we currently do is we have people on these PV plants. Either they stay in these plants, always monitoring them, or they basically visit once in a year, twice in a year based on geography, right? So there's quite a lot of loss which is built up through these years, right? Now, what do we have to do in such a case? We can't really have people go around and actually lose this much energy throughout the year, right? So our thought was rather than putting up millions of sensors, which become so expensive, what if we have one sensor which automatically moves around, and if we are able to identify these issues in such large infrastructure? And that's where we came up with our solution at AIRPROBE, which is the drone acts as a carrier of this particular sensor, right? We collect images through these drones. Now by images, it could be basically thermal data, which we call as thermography, which is a way to detect heat losses at different phases, right? And what we see is when these PV panels basically underperform, they basically heat up, right? Because you lose energy as heat rather than produce electricity over there. So what we do is we pick up these signals of underperformance from these so-called inverters. So we know targeted area where there is performance loss, and then to identify what these issues are. And even before you go and try diagnosing the issue, you can directly go and fix it up in one single truck roll, right? And again, as mentioned, our thesis is there's a huge amount of loss at this phase, which I'll be speaking through a small case study right now, right? So let's look at something called as commissioning of solar PV plants. What does this basically mean? You build up a solar plant and then you want to start producing electricity. And for that, you basically connect it to the grid, right? When this happens, there are multiple activities which happen in these PV plants because they're so large. There's still construction happening in a few phases. You're trying to identify problems to rectify so that there's no fire hazards, there's no damage, etc., right? And just through this representative image, you can see what I mean by large, right? Through an aerial view. Now, what are the typical problems and what's the effect? We see that there's 2 to 5% of performance loss in the first 3 to 6 months in these solar plants. Now, that is huge. When we're speaking about a 300 megawatt plant, a 3% is close to 9 megawatts, of solar plant which is not even connected, which can power thousands of homes every day, right? So basically you don't have your SCADA systems which are available at that point because you're just commissioning the plant. Manual labor is expensive or it takes 3 to 6 months. So there's huge amount of power loss and there is damages across these PV plants which can lead to potential health and safety hazards, right? So what we propose is actually using drones where we are able to cover 30, 60 megawatts a day through a single drone, which automatically goes and collects data, right? And then we upload this onto our platform, which we offer through AIRPROBE, where AI basically automatically detects patterns in these images to identify issues in these panels, right? And then pinpoints these locations, right? So this is some examples of what I say with respect to what we see and what our machine uses to detect power loss, right? They're all different patterns. Some like checkerboard, some like broken panels, which are obvious. You can even see trees causing shadows in certain last images, right? And then basically what we've observed in this case is we are able to identify all these panels which could have manufacturing issue. Basically, these panels need to perform for 25 years plus, and they have issues right at installation. So you can get an insurance or a warranty claim. So this makes the asset much more reliable for these PV investors, which means you can invest into more and more solar plants to provide more renewable energy, right? But the most important thing which we observed at this phase is 12 megawatts is not even connected to the grid, which is a huge amount of power loss, which I'll quantify in terms of number of houses later, right? So what that means is there is an immediate ROI which we are able to achieve at this particular phase using technology. If not for which, we would be losing a large 12 megawatt solar PV plant, not even connected for the first 6 months, which just doesn't make sense, right? So this is a clear representation of what we see. So not just trying to save money, but in fact, for the PV investors or the owners of these assets, they're actually making more money by using drones at this phase because they're able to identify issues in 5 to 10 days, which they would typically take 3 to 6 months, right? Now, basically, we started delivering our results in terms of PDF copies, etc. when we started. But then we realized, hey, it's not just that drone moves fast across large infrastructures and collects data, but it also has geospatial information. So we can actually identify every panel, where is it located, so that you can go ahead with targeted fixing of these issues. Everything could be automated in a future where a lot of these robots could go and fix up these issues, right? So we came up with a digital platform where today it's not just data from drones, which are geographically collected. We also collect data from different sources, which could be the monitoring devices, certain performance evaluation devices, etc., which is basically what previous speakers spoke about as digital twins. So now we are able to simulate everything online and identify how much would it cost us, how much energy do we actually save, what is the production loss, much before we try fixing any issue. So it's much more targeted in nature today, right? So this was just one example of what we do. And when we look at drones in a broad spectrum in solar PV, they're used across the life cycle. What do I mean by that? Can we put solar here? How much will I produce? We can look at land surveys. We can look at certain preventive measures, like let's say with climate change, we see a lot of disasters, which is also a problem for renewable energy assets. We see a lot of older renewable energy plants completely submerged underwater. There was a cyclone which completely damaged the entire plant and it just doesn't make sense to install. So basically we help in these feasibility reports basically early on to identify if there could be flooding in those areas on a very accurate level, how to really design these plants, etc. Then comes the construction phase, where you basically identify if construction is according to the plan, if quality is working out well, so that these issues can be resolved early on. We are able to help in performance evaluation, which is the example I just showed to you right now, and also in terms of digitization, because we are using drones to track serial numbers of every component geographically located so that all further actions could be automated. What does this essentially lead to is to help generate cheaper energy, which is the goal to promote more and more renewable energy. We already see solar PV is the cheapest form of energy in the latest bids. We are here to make it much more cheaper than that using technology. Right? And this is just an instance of what we are able to achieve, right? In the 12 gigawatts which we have inspected, 120 megawatts was not even generated. What does that mean? It is close to 96K homes which could be powered with the same energy, which was lost and not even produced, right? So when we speak about technology for good, we do identify that with advanced robotics, AI, we are actually able to efficiently do it and help our customers save money, and hence they can promote more and more use of technology, right? Thank you so much for the opportunity and really appreciate it.
Much for that very interesting presentation. It's really good to know what AIRPROBE is doing, especially in the areas of renewable energy sources. Really, a lot of opportunity exists, and I think the products and the technologies that your company are working on certainly will improve the efficiencies and the output from such systems. So thank you very much for that.
Thank you so
Aditya.
much.